are new, I like to do a brief introduction. So first of all, let me see if this works. My name is Edwin Robledo. I'm part of the Autodesk team, and I was actually part of Eagle for a long time now. So I've been able to see its transitions throughout its time, and it's been very exciting. And I can't tell you enough of the new, more exciting things that are coming with us. Jorge and myself, we're located in South Florida, approximately, I don't know, like 20 minutes just north of Miami. We're near the Fort Lauderdale area. Jorge has been with us approximately, I would dare to say, yeah, it's been a little over 10 years now. We've been working together. We've been support specialists for Eagle, and we've been able to participate in several events. Now, just want to give you a brief intro. Eagle actually consists of multiple platforms, and all these platforms talk to each other um, because they're required. They're almost basically required to be able to work, but they work in separate platforms. So it's one platform, but separate editors, is what I'm trying to say. So we have the schematic editor, which we covered last 2 days ago. And from the schematic editors, where you're going to actually create the logical aspects of your design. This is what you're going to be seeing, see if you use any type of simulation. And here you're going to be putting it together based on symbols that you use on the schematic. Today, we're going to be covering the circuit board. We're going to be working with the physical aspects of the circuit board. Here, we're going to actually be working with the components that are going to be provided or that you'll be using for your design in a physical realm. Okay. And then the other platform that we have is called PCB libraries. PCB library platform is where you're going to actually has multiple workspaces in which you can actually create your components. There's a symbol editor, there's a package editor, and there's a footprint editor, and then you put it all together in something called a device. And we'll be covering webinars based on the library later on next month. Now, today we're going to just do a brief little view of the control panel. Not much because we went into detail last week. And if you haven't seen that, that recording is going to be up and running really soon. Now, today we're going to concentrate mainly on the circuit board. We're going to convert the design that we just created just recently, converted over to a board. From that board, we're going to actually create an outline in Fusion 360 and see how can we import that outline onto the board. Then we're going to go ahead and start placing our components on the board. Testing, testing, 1, 2, 3. I'm good now. Sorry about that. I paused there for a second. I was told that I dropped out for a minute there. We'll do some manual routing and some auto routing. And if we have some time, I actually want to try to go into the CAM processor as well. Just want to let you know that Eagle actually has something called real-time forward and back annotation, meaning that modifications done to the actual schematic actually affect the board in real time. And there's some modifications that could be done to the board that will affect the schematic. And we'll go into that a little bit throughout the design. Now, the last but not least, we want to go into the CAM processor. This is where we're going to produce the files that actually get your board manufactured or prototyped. Even though many board houses accept the native Eagle file, it's always a good idea to learn a little bit about how the CAM processor works as well. So let's go ahead and go live with Eagle. Okay.
You have too many things open, Ed.
Never. There's never too many things open, George. Okay. Okay. So this is a control panel. As you can see, it's subdivided in multiple sections for our libraries, our blocks, design rules, and a scripting language that is available. One of them is called scripts, and the other one is called ULPs. I suggest you get into the ULPs because there's many, many, many very useful ULPs that you could get from here. One of the ULPs that Eagle has is most commonly used is the one that generate your bill of materials, as well as the ULP that create the pick and place information to get your boards automatically populated. Okay. Now we created a project on Tuesday, and from the projects we went ahead and I expanded projects and we created this webinar 2019 project. As you can see, it's still in green because I still have it active. And based on that, we created our schematic. Let's go ahead and open up that schematic. Okay, this is what our schematic looks like. This is what we created on Tuesday. Plates our components. We created our connections. And from there, we're going to now go ahead and create our circuit board from this point on, okay? Now, there's a little icon that you're going to notice on the top right-hand bar right here. You're going to see it right here. 1 second. Hopefully you see it right there. That icon that you see right there, that's the icon that we're going to be using to convert your board over to a schematic, okay? So let's click on that. It's going to prompt you, do you want to create a board based on the schematic? And we're going to go ahead and say yes this moment. Depending on the subscription that you have, you'll notice that you get all the components on the left-hand side, but depending on the subscription, this default board outline is going to actually show up, okay? Now, you could go ahead and just click and drag on the edges of here and just make this a little bit smaller. Oops. Oh, much smaller for our case scenario. But we also have the alternative to actually, if you have like a complex outline, Eagle is mainly a CAD program for circuit boards, so it doesn't really have all the drafting tools such as a mechanical tool would have. And I'm going to show you a little bit of how you could actually take advantage of the collaboration that we have with Fusion 360 to create a really nice board outline. So I'm going to go ahead and fire up Fusion 360, which I actually do have it open here, right here now. I'm in a project called Webinar. As you could see, let me go ahead, Webinar 2019. Right here on this project. Actually, let me see if I have another one that is blank. Webinar demos. Okay, so we could stay here. Webinar February 21. That's the name of my folder, my project. That's the name of my project. And then what I'm going to do is I'm going to go ahead and I'm going to draw a board outline in Fusion 360. To draw a board outline in Fusion 360, it's really easy. You're going to go ahead and click on the sketch command. The first thing that's going to ask you is what plane that you want to draw the sketch. I'm just going to select the X and Y coordinates right here. And that's where I actually want my plane to be drawn. Now I'm just going to go ahead and use the line command here that you see here in Fusion 360. And I'm just going to draw a shape. I'm not going to be very specific about my shape. I'm going to give it a height of 30 millimeters, a little bit more, give it 35. And I'll go down here. Okay. Should use maybe it had drawn a box. As you can see, you could actually type the dimension when you're drawing your line if you wanted to. There's a little bit of a lag here going on, George. Yeah, there's like a lag going on. So when I'm drawing it, I feel the lag. Okay, that's what I'm going to be using as my board outline right there. Just going to constrain some of my measurements here. I want this to be not 10 mil. I actually want those to be 5 millimeters. No, 10 millimeters good. I want to leave them at 10 millimeters there. And my height, let's see what my height is looking like. And it's 35. I'm going to actually change this to, let me see if I could go to 40. Okay. And do the same thing on this side over here. That way it looks even. Okay, very well. And this is going to be my board outline I'm going to use in Fusion. I'm going to finish my sketch. Now I'm going to go ahead and click on Create Circuit Board, Create PCB. I'm going to go, this now takes me to the PCB platform. I'm going to select this shape, this body that we just created, this body that we just sketched out. And from here, I'm going to actually create a PCB. Here we go. Create PCB profile. There's our PCB. Okay. as you could see. This is going to be my PCB here. Now I want to define in Eagle where I want the origin to be. This is the origin that Eagle is going to see, and I actually want the origin to be there, and I want this bottom to be my x-axis in Eagle. So I'm going to click reorient, and I'll select right here, and that's going to be my x-axis. Once I click OK, now we have our circuit board. You know what? But I did forget how to put some mounting holes on this board. So let's go ahead and roll back our timeline here on the right-hand side and edit our sketch. That way we could just put a couple holes in there. There's I'm still in the PCB drawing space area. Okay, so let's go ahead and edit my sketch. I'm just gonna use the circle command and put some 3mm holes here really quick. Okay, very well. Hopefully that works out. Let's click on Finish PCB. I'm sorry, Finish Sketch. There's our sketch with the new holes. Now if I roll back my timeline, I should be able to see those holes on my PCB, as you can see there. Everything goes right. And I do not see them. Oh, yes, they are. They're there. Yeah, they're there. Sorry about that. They're just really small. Okay, now that I have this, I'll go ahead and save what I've done so far. And it's really important that you remember what is the name of the project that you're working on. If I'm not mistaken, I think we're working on here on this one right here. That's where it's at, webinar of February 21. As you can see, my circuit board is already done. Now I'm going to go to Eagle and I'm going to go ahead and import this. So I'm going to go ahead and click. Now I'm back in Eagle. I'm going to click on the Fusion flyaway menu that you see here. I'm going to link to an existing design in Fusion. I'm going to link. I don't want to push a new one. I want to link to one that's already created for me. This is going to show me all my projects that I have in Fusion 360. As you can see, it's loading. Okay, excellent. So let's look for the one called Webinar February 21. So it'll be towards the bottom. Here it is. And here's that circuit board that we created right here. PCB1, and I'll click OK. I'll pull from Fusion first. I'll pull. Just wait for it. Okay, apparently I did my orientation wrong, Jorge. Yeah, apparently I did my orientation. I thought apparently I did it wrong in Eagle, in Fusion 360. So sorry about that. I intended this to be on the top left corner.
Yeah, and this can happen because remember that Eagle is 2D, whereas Fusion works in a full 3D space.
Yeah.
So you have to be careful where you define the corner. The best place to define the origin on the sketch is the intersection of the X and Y axes. So if you do that, you'll generally get it where you want it to be. But it looks like Ed got it from a different spot.
So I selected this corner here, Jorge.
Okay. So
I wonder if because I selected a different plane or something like that. So that's
right,
my
that's
origin.
your X-axis. There you go. That'll work.
That should work.
Yeah.
Let's go ahead and save what we.
Wait, you gotta finish. You gotta finish PCB. Finish.
Yeah. Okay. Finish PCB.
Now save.
Now let's go ahead and save. Updated orientation. It's really important to put some sort of a notation here. It's always a really good idea. And you're going to see why now in a minute in Eagle. Now that it's saved, I'll go back to Eagle. As you can see, it's in red, letting me know that there's been some modifications in Fusion, and it wants me to pull that project again. So when it's in red, that there's been modifications in Fusion, it wants you to pull it in. If it's green, there's been some modifications in Eagle, and it wants you to push it back to Fusion is what it means. So I'll pull from Fusion again. Okay, and let's see if that works. Okay, no, it does not change, Jorge. So apparently I have
Check it
something
because
wrong.
remember that you wrote a comment, and when you did the pull from Fusion, it didn't show that comment, eh? Oh, there you go. Now you'll get it.
Apparently I'm a little behind.
Yeah.
Somehow it's a little behind. It pulled the first one again, is what
Right.
it did. It pulled the first one again. So maybe when I did it this time, it was still saving in Fusion,
Hmm.
most probably. So let's see if this time it works. Nope, stayed exactly the same. So apparently I have to check that to see that. So
Make sure that in Fusion you have it the view of the PCB as it is in Fusion and not Eagle. You know. So if you check out the PCB and you edit it, where it says status, make sure, yeah, Fusion board shape. Compare it to Eagle, and you can see if it's any
it
different.
doesn't let
Oh,
me. So
okay. So it's the same. They're both up to date.
they're up to date. Yep. So I have to test this offline anyway. But I just wanted to be able to you see that you could draw complex outlines in Fusion 360, even though this is not a complex outline, and easily bring them into Eagle and make that your board outline. Now let's go ahead and start putting parts in our board layout. I'll go ahead and use click here. I have that command open. Let me put some of my LEDs. I'll put this one here. Put this here. You see that I'm by mistake. It's trying to grab an air wire. To avoid this and make it a lot easier for you to move parts, as you can see, I have the selection filter here enabled. I'm going to go ahead and select where it says devices, device, here on the selection filter. So from now on, whenever I try to select something, it's only going to be selecting devices. It will not select anything else. This just makes it that much easier for you to select components and not be using other components by mistake, okay? So no matter what's near the origin of the part, doesn't really matter. It's going to only grab the component. Now this component that I have here, I actually want to mirror it, this battery. So I'm going to right click it and select the option mirror because I actually want it on the bottom side of the board, as you could see there. So I just did a right click and selected mirror. I'm going to go ahead and select my caps here really quick. Oops, I still have the mirror command active. Sorry about that. Let's mirror it back. Okay, and go here and select this here. I'm just doing a random positioning, so don't. Okay, and I'm going to move these as a group. Okay, let's do a zoom to fit. Okay, very well. Now, as you can see, all these air wires are kind of all jumbled. There's a command in Eagle in which it's going to actually optimize all these connections, and it's called a rat's nest. And that's this icon that you see right here. This is the rat's nest command, and it's going to optimize all these connections that we have here. Okay. Okay, so I guess it worked. You also could type the command rat's nest if it's any easier for you to work with that command instead. Now, as you could see, okay, so there's a few things I would like to show you here that I don't think I've shown them in previous webinars here. So let's say, for example, I have this group of resistors here. I would like to kind of align them. Okay, so I'll go ahead and select. I want them to be aligned evenly. Oops, I'm sorry.
Undo, undo.
I am, but I just have this menu here on top. I'm gonna do the undo here.
Yeah,
Okay.
gotta keep undoing. There
Okay,
you go.
there we go.
I think the one you want is on the end.
Oh, there it is. Yep, that's the one I want to use. There you go.
There you go.
So as you can see, we could align it. Other thing I want to do is I would like to just kind of make the attributes just look a little nicer. So I'm going to use this the attribute move attribute option, and it kind of gives us a whole bunch of really neat attribute repositioning right there. That one, attribute reposition. So let's say, for example, I want them on the let's say we want it on the kind of on the right hand side. So I select here. So now I select here. Oops. I have to select, I want the name and value to be moved. I could click there, click there, and click there. Okay, so let's go ahead and move these apart a little bit. Oops. Actually, you know what? Let's reposition them somewhere else, or George, because I don't. This is going to be a lot. It's going to be a lot of work to do that.
Pick, yeah. I was gonna say bottom. Yeah, I got it. Perfect. Boom. Almost perfect.
Almost. I'll put those on the top.
That may work.
Put that one on the top, and that one almost worked. So we'll leave it as is right there. Now, somebody was asking how about the dimension of the board. Here's a tool right here. It says dimension. You select this tool right here called dimension, but you got to make sure that you select the correct layer where you want the dimension to appear. I'm going to select the measurements layer, and I'm going to go ahead and select right here. Let me go to a smaller grid. There we go. So let's go. And that's one way you could put the dimensions. That way you could document your board size if you want to. Another option that you have is just clicking here on the manufacturing screen that you have here. Okay, here you could get some board data. It will actually tell you the board area right here, as you could see here. So that's from the manufacturing window that we have here. We have a layer stack up, so you'll get all that information from right here as well. Okay. Okay, very well. Okay, now that we have placed our components, let's go ahead and stop what we have so far. I'm going to reset my selection filter. That way I have all the choices of doing whatever it is that I need to do. Click on dimension and just do the dimensions of the board as well. We could get it from here. Which is that grand total that you saw in Fusion 360 as well. Now that we've already put the board together and laid out the components where you want them, now we have to go through some routing routines. Now, one thing I did wanted to show you really quick is the following. Let me just bring up the schematic really quick. Here on the schematic, if I go ahead and in the schematic, if I delete a component in the schematic, see the reaction that's going to appear here on the board. I'll delete this component right here. And you could see in real time, it actually disappeared from the board layout. This is what we mean by a real-time forward-back annotations. Modifications done to the schematic will actually affect the board immediately. I just wanted to show you that really quick. Very well, back on the board layout now. Now on the board layout, usually once you've done your placement of your components, the next stage is actually to start the routing. I'm going to show you a couple routing techniques that Eagle offers, especially the manual routing tools that are actually interactive and extremely useful. Here's the routing icon right here. Now, if you look carefully, you're going to notice that there is a little sliver drawn right there. You see that little sliver right there? You could see that. Okay. That brings down all the manual routing tools that are available right here. Okay, so I could select the route air wire, this one right here.
Yeah, you can also get it through right click.
So as you can see, it's the line is kind of thin, and it's kind of following a rule by DRC. It's setting up the rules by DRC. The DRC stands for Design Rule Check. So if we go here to DRC, which is this icon on the bottom left corner, it's setting up a size of 6 mils as my routing for this board. I'm going to go ahead and change it to 12 mils. Click apply. That way you could see what happens. So now when I do my routing, sorry, I do my routing, I should be able to go, as you could see it change up on top to 12 mils because that's what I have set up on the DRC. So now I could go ahead and do my routing. Do some routing. I'm just going to do a few of them just for examples. So here's one route. Now it will automatically snap to the connecting point of the pads, okay? So let me do one more. It automatically will snap to that connecting point, and then it lets me route to the next one. Now, let's say, for example, I was actually routing and I need a point of transition, for example. Let's say, go here, do this one really quick. Oh, you know what? This is actually a perfect opportunity to show you on this straight line here, another routing tool that we have called Quick Route. So if I click on the sliver here, you're going to notice here it says Quick Route. For really simple lines like this one, sometimes it's just best to use Quick Route. You just click on it and it will actually route the line for you. Okay, so things that are really, really straightforward and very simple, it's not a bad idea to actually use Quick Route. I'll use it one more time here for the LED. Okay, I'll go back to our regular manual routing AirWire format, and you're going to notice that there's 3 modes that I could use. I could use up on top on the parameter toolbar right here, this bar right here. You'll see that I could push obstacles or I could go full manual. If I'm going full manual, it's going to allow me to do basically any violation that I want. I could cross other lines, I could cross on top of pads and so forth. Those hatch marks that you're noticing there, it's just DRC letting me know, because we have live DRC. It's just letting me know that if I go in that path, I actually have a violation. So this is real-time DRC. Now, let's go ahead and enable the push and shove router. If I click here where it says push and shove, this router actually will try to force itself on and move objects out of the way, other traces, I should say. So as I route, as you can see, it will try to push those items out of the way, as you can see. Now, if I'm routing and I did a left click and I have a point of bend there, and I want to go back, you only have to hit the backspace and it will actually return. It will eliminate. And if you have many bends, let's say, for example, I go 1, 2, and 3, I can now hit backspace, backspace, backspace. That way I could backtrack. Now, let's say, for example, I want to go through here to follow my path, to go through, take this path, to go to that resistor that I need to. So at this time, you may want to consider placing a via. A via is just hit the space bar, and the via is going to be attached to your mouse cursor. Now, the via is not going to be placed. It's going to remain attached to your mouse cursor. Now, if you look on the top tool, at the status bar at the bottom, let me show you this right here. If you look at that bar right there, that status bar right there, it's letting you know that when I start routing this line, when I'm back to routing this line, it's actually going to go to the bottom layer. If you had a board file or a design that had more than 2 layers, let's say it has 8 layers, it's always a good idea that when you hit the via and it's attached to your mouse cursor, that way you could see what layer it's going to go to. If you have more, if you don't want to go to that layer, just keep on hitting the space bar and it's going to go ahead and cycle through all your layer options, okay? I just wanted to bring that up really quick, but I just thought it was extremely useful to learn that. Okay. Now, since I only have a 2-layer board, when I left click, now it's going to start routing on the top layer, as you could see. So I could go ahead and finish this route. But then again, I can't route to here because I'm on the bottom and that SMD is on the top layer. So I'm going to go ahead and hit the space bar, put in a via down, and just go ahead and complete my route here as well. Now we do have the possibility of routing multiple lines simultaneously. I'll see if I could demonstrate that on this part right here. So we have here where it says route multiple air wires right there. That you see that. And I'm going to use this line. As you can see, there's a little line showing up and it highlights the pads. I'm only going to try to route those two. Okay. And then now, always when you don't know what's the next action to do, always make sure that you're looking at the status bar because it's telling you exactly what the next action you need to do. It's right there. Okay. So it's always make sure that you're looking at that because that's what's going to tell you what your next action is. So it's telling us we need the right click to start the route. And as you could see, I could start routing. Now there's some shortcuts that we could use. And if you look at the status bar as well down on the bottom, it's letting you know that you have a command line minimal spacing, increase spacing, or decrease spacing. A lot of these are actually already assigned to short keys. Let me see if I still have those assigned. So yeah, I do have them assigned, and they are assigned to Alt D. Okay, so Alt D. So it will decrease my spacing, and Alt S will increase it. Okay. So this is one way that you could use to actually, but this is not differential pair routing, okay? This is not even close to differential pair routing. This is just being able to route multiple lines simultaneously. Very useful if you're like in a bus configuration and the lines are just straight across. You only have to do some short bends. And if I'm not mistaken, you correct me if I'm right or wrong, Jorge. I think you could go up to 16 lines at the same time, 16 different signals at the same time.
That is correct.
Okay. Now I'm going to go ahead and stop what I hit escape to just get rid of that. Now to get rid of a trace or a segment, you need to do that using the rip up command. The rip up command is right here. This icon that you see right here. This is what you're going to be used. Now you're going to get multiple options on the toolbar right here. Okay, the first and the default one is per segment. So it's going to actually rip up per segment, as you could see. Now you have other options here. This one is if I just want to do the entire segment or all of the segments that are on the same layer. Here are all the segment, everything that's connected to copper from one point to the other one. I'll just use that one right here. And as you can see, it's all gone from one point to the other one right there. Okay.
Correct. And you can also limit it by layer. So you have
Right here,
besides,
yeah. On the same layer. So if you click on a trace that has multiple instances on different layers, on the segment that you click on, let's say it's on the top, it's only going to rip up all those segments on the top layer. Okay. And then here you have per signal. So let's say you want to, here on signal, it's actually kind of useful on signal because I could click on a particular trace on the board, let's say ground, and if I use this option, if I click on that, it's going to rip up all my grounds throughout the entire board, as that one's going to do. Okay.
Yeah, use with caution though, because it can be a little bit of an elephant gun, you know? You can blow away all of your.
And then this other one is actually, I don't use it very often, but it's actually pretty useful if you need to rip up all the traces between two components. That's this last option that we have right here. So you click on component A and then component B, and it rips up all the connections between both of them. And here, if this one, extremely cautious with this one. I'm kind of glad it's a red X because you should be very cautious. What this is going to do is that it's going to rip up the entire board. Okay, it's actually going to rip up. It's going to rip up all the signals, and you could say yes, and you could see everything goes back to its AirWire format. If you have polygons that are filled in, and I'll go ahead and create a polygon really quick. There's a couple ways you could go through a polygon to create a polygon. I'm going to actually demonstrate both of them. This is the polygon icon that we have right here. I'm going to click on that polygon, and I'm going to start drawing a polygon. I'll do it really quick because there's two ways I want to do it. I want to do my polygon. Now the polygon doesn't really matter if you're shorting things out or like that because it's smart. It's going to automatically calculate itself around items that do not belong to the polygon. It's asking me for the signal. I'll just call it ground in this case. And now to have the polygon calculate, you're going to run what's called the rat's nest command. As you could see, it actually totally fills in. But let's say you need to get rid of the polygon because it's just in your way. You'll notice that the polygon automatically created thermal connections to those pads and vias that are already conducting ground. That's automatic. That's what you see, those thermals here. Okay. Anything that does not belong to the polygon will get an isolation ring. But let's say we want to get rid of this polygon now. What you're going to do is that you're going to click on the rat's nest command again, and you're going to click on this icon right here, all visible polygons, and it will put it back in its outline form. Okay. Another way of creating a polygon is by right-clicking. Let's say you want to cover the entire board. I just right-click on the outline of my board, and I say convert to polygon. And I don't want to replace this outline. I just want to take that shape, and I want to copy it. In this instance, I'm going to take it to the bottom layer, and I'm going to go ahead and click OK. You'll notice if I zoom in a little bit, the entire outline has now become a polygon. If I run rat's nest, on it, it will go ahead and calculate. There's my polygon right there. Okay, so there's one on the top and there's one on the bottom. You're only noticing the one on the bottom because my preferred layer at this time is the bottom layer. I could go ahead and change that to the top layer, and you'll see now the top layer actually becomes my preferred layer. So now I see the polygon on the top. Okay. Now let's go ahead and rip this up. And let's go ahead and actually switch this component from a surface mount component, from a through-hole component to a surface mount component. So I'm going to use here the selection filter, and I'm going to select devices again. That way I'm only selecting devices. It will ignore anything else. I'm going to go ahead and right-click on this component, and I'm going to select the option not replace, but package. Right here, package. This component actually has been created in a way that I actually have the capability of selecting if I want to use a DILO 8 or SO8. I'll go ahead and use the SO8 and click OK. As you could see, now the component has switched from a through-hole component over to a surface mount component, and it will keep the position that it originally had. The X and Y coordinates, the origins will actually match. Okay. Now, let's go ahead and try using the auto router on this board. Hopefully that the default parameters will actually work really well. So let's go ahead. This is the auto router icon right here. Oh, before I do that, let me just do a quick fan out. That way you can see how fan out works. A fan out. And I want to fan out grounds. So this one is carrying ground. I have multiple configurations I could use here. I could fan out a device. In this case, I want to fan out a signal. And it's going to go to the outside of the component, as you could see here. If this one would be to the inside of the component, and this one would be alternating. I just want it to fan out to ground. Okay, now I'm going to select this air wire because I know for a fact it's carrying ground. So if I click on there, you notice that now it's fan out everything that was ground. It's just fan it out to a via. So all my connections here, all the surface mounted ones, of course. Okay. Now let's go ahead and use the auto router to take care of the rest of the board. Here's the auto router icon right here. The default settings are pretty standard. This is a two-layer board, so it's going to use any direction on the top or on the bottom layer. If I click on the down arrow, I could select preferred directions. Now, it doesn't mean that it's going to actually follow that direction. This just means that that's your preferred direction on that layer. This is mainly for aesthetic purposes. I'm going to leave it an auto. The effort, I'm going to select it to medium. That's just how much effort it's going to put onto the board, and it also determines how many threads are going to be running for the board. That's how many threads that it's suggesting it's going to use. It may use less if there's just not enough alternatives for such a small design. Now, I am going to allow it to use the top router. That's kind of a second algorithm within our main auto router, in which it's going to try to route the board in a single-sided if it's possible. Doesn't mean it's going to always going to be able to accomplish it, but it's going to try to keep it in a single-sided mode. Okay. Now I'm going to go ahead and click on continue. If there were any other changes I wanted to do, and this is kind of an expert mode, I could click on the double hours here, the arrows, and here I could actually set up more kind of fine tune the behavior I want the auto router to have, like how it's going to treat the polygons, my preferences if it goes to the top, my preference if it goes to the bottom, how does it bend, and so forth. This is kind of a fine tuning option. Really don't really mess with it, but if you do, if you go to the help file or to the manual, you could actually, fine tune what you need to be done. Okay. Now I'm going to just go ahead and click on start and let Autorouter do its thing. Okay. As you can see, I decided to run a total of 10 runs on the board. We have multiple results already done. All of them actually are done. And if I was to, let me just get rid of this screen right here. And if I was to click on them, you could see the different ones that are actually accomplished. Of course, I'm going to select the one with the least amount of vias, but that doesn't mean that's always going to be the appropriate selection. You select that one for our intents and purposes. Now, there's one observation I want to do here. So to finish the job, once I've selected, I found the one that I want, or if you want to keep on evaluating, you could click on the evaluate button here. That way you could evaluate what's going on that one that we have selected. But if you want that one to be final, you must click down here. So let me show you. There's a right here. I don't know if you can see my arrow there. Keep on doing more arrows until you could make sure you see that there. Down there on the right hand side, okay? I hope I didn't exaggerate that much, but that should prove the point. So you click on here, a little right there, and it knows that you're in an evaluating mode. And then now I could either continue to evaluate or I could just end the job. That way I could select that one. Okay. Now that I've selected the job that I actually wanted to look at, let's take a look at what's going on here. So it's actually routed 100%. Actually doesn't look that bad. Looks actually nice and clean. We could get rid of the polygons, just that way we could take a better look at how it routed the board. And as you could see, this air wire is only there just because the polygons are not poured. Okay, that's why. That's a ground connection. That's the only reason the polygon is actually there. Now, if there were some routes that, and I don't know if it will be able to accomplish this now, but there's some routes that you could use what's called a smooth router. Let me see if I could use that now. So let's say we click here, and you have here what says smooth router. If I select this line, I don't know if it will do anything. As you could see, it straightened it out right there. Okay.
Yeah, and
This,
just a little point, Ed, with the auto router. Remember that the top router can take a lot longer than
yes.
normal routing. Like this was an easy board, so it was about the same. But on
Mm-hmm.
most boards, it'll take considerably longer. And also with the auto router, you have to make sure that at some point you click end job. You have to at some point click end job.
It,
Otherwise, you'll leave it floating,
yeah,
and that
and from that point on, if you continue doing any work, you're gonna lose it basically because it's gonna want to end. It's gonna when you do end job, it's gonna load the original
right,
board.
it's gonna want to go back. So please make sure always at some point you hit end job before you continue working. Very important.
Excellent. Thank you, Jorge. Appreciate that, man. Um, So as you could know, you could do the smooth router if there's some bend, and it will see if there's an opportunity to actually do it. Now, just a point I want to put across as well here is that um, the auto router will not touch or try to optimize anything that has been manually routed. Okay, it's going to be totally ignored. So it's okay to go ahead and go crazy and manually route everything on the board as much as possible. And then those that are just really easy routes, like straight lines, some of that, then you may want just the auto router to take care of those for you. But we always strongly recommend that you go ahead and use the auto router, use manual route for as much as you can. Okay. Now there's one more tool I want to show you here before we end our demonstration is the miter command really quick, because I get this quite often on support questions. It's this icon that you see right here, this one, miter. You have two options for miter. It's either a 45-degree cut or a rounded cut. So I'm going to select the rounded one, the radius one, and I'm going to go ahead and click right there on that corner, and you could see, oops, I have to reset my filter because it's not letting me select it. Okay, so I'll click right there, and as you can see, it's just I could round off my corners really quick. Okay, this kind of ends this part of the board. I'm going to go into post processing now. Okay, very well. So let's say this is the board we actually want to submit, and we actually want to produce. I'm going to go ahead and click here. There's two ways you could go about it. I could do it from the manufacturing, and I actually like to doing it for the manufacturing, and there's a couple of reasons why I like to do it. So you have the manufacturing icon there, or you could have the icons right here. Now there's two ways we could go about it. We have right here where it says generate cam data. The generate cam data is it's almost a two-click solution. Basically, it loaded a template because it realized that this is a two-layer board based on my DRC. I'm going to go over to DRC. I'm going to go to my layer stack up. And here I have it set up as two layers, the top and the bottom layer, layer 1 and layer 16. It's a two-layer stack up only. If I wanted to add more layers to this, if it was a 4-layer setup, I would click here. It's only a 2-layer stack up, as you can see here. Therefore, when I click on this one-click solution where you have right here, it automatically, since I had 2 layers, it loaded a 2-layer template. It's gonna create my top, my bottom, all of my profile, which is my outline, my silk screen, my solder mask layers, and my drill files. Everything is going to be created for me. Okay. So now I'm going to go ahead and click OK, and it's going to zip it up. And it's going to place this file in the exact same folder wherever this board is located. Okay. So I click OK. And the file was created. It's asking me where do I want to put it. So that's the file it's going to create. And I click on save right there. I have to confirm where I want it to be created, and that's done already. Okay, and the file has been created, and it's there. It's ready to be sent to the board house if you want at that point. Now, let's say you want more control of it. You want more control of how you're going to generate your outputs. From that point, you could use this icon, which actually will take you there to the CAM processor. You'll notice that it also will load automatically the 2 template data here. But let's say I want to get some more statistic information on the board before I actually go to the CAM processor. I'm going to go to the manufacturing here. And here I'm going to see a lot of information on my board. Besides the fact that I could preview it from between top and bottom. I could preview the top as well as the bottom side. In addition to that, on the board here, you get a lot of information. You get how much copper you have, your board thickness, all of the routing statistics, your drill files, how many pads you have, and then the drills. It actually will give you a map out of your plated through holes and your vias as well, and your non-plated through holes if you had any holes here which were not plated by any chance. Okay, I'll go ahead and click on close. And from here, I could go back to the preview. And from right here, I could load the CAM processor. Now, this is the long form of the CAM processor. Okay, this is our long form. Okay, so the first section we have here is called Gerber files. The Gerber files, what we use is a 274x format. Okay, that's the format we're using. And we're using 3 integers and 4 decimal points. That's the format that's actually being used for our Gerber files. You'll notice that it's going to create the copper top, bottom, and then it's going to create, and you could actually preview it there on the right-hand side. So you could see it's actually, you could preview the bottom copper. You got your outline file. This is the profile, the outline of the board. You got your solder mask, top and bottom, and then you got your solder piece, top and bottom, and then you got your silt screen, top and bottom as well. Okay, so that takes care of all your Gerber files. When it comes to the drill, this is just the drill file output. The file is going to be called XLM. Oh, I forgot to do this here. Here's the file that it's going to be exported. This is actually the file is going to be called copper underscore top. This is my Gerber top layer, and it's going to place the file in a subfolder wherever my board resides. Okay. In addition to generating the Gerber file and the drill file, it will create a bill of material. It will also generate a pick and place data as well. Okay. Now let's say, for example, I wanted to add additional information to one of my layers. I will click, let's say, my profile, and I could click here where it says here, edit layers, and I could actually add an additional layer. So let's say you drew additional information on a different layer, and you want that information to be part of a particular Gerber output file that you need. This is what you would do. You would select that section or create the section and go here and select that's right there. Yes, in case you missed it, I'm gonna, because this is for me rather important. It comes up often right there, that icon that you see right there. Okay. Click on that right there. And let's say, for example, I want to select layer 20 for this as well. You click on layer 20 and click OK. So now layer 20 is going to be part of this Gerber output as well as we do here. Now, you have the option if you want to zip it up. I don't want to zip them up right this moment. Okay, it's going to use metric units. Depending of your board house, depending which board house you're using, but I think the majority of them use metric, to be honest with you. And I'm going to go ahead and click here where it says process job. Okay. And then I'm just going to click here where it says open because it actually finished. I'll open up the folder. And I think it opened it up over here. Let me see which finder did it open it up. It opened it up on my other screen. Sorry about that. Okay, and this is the subfolder where I created it. So this is where all my Gerber files are located. Here are my Gerber files. Here are my drill files, and here are my my assembly files, which basically is the pick and place, as well as my bill of materials. Okay, well, this ends everything that I wanted to cover today. We'll go ahead and take care of some Q&A. I went way over the time that we really, I know we started a little late, but this is kind of, takes care of all of everything, every aspect that you need to do on your board to actually get laid out. There's a lot more tools, of course, but this, in essence, is everything that you'll be requiring to actually have your board laid out. So let's go ahead and do some Q&A, Jorge, if you think there's anything that I need to work on here. Oh, let me check our YouTube friends. Hey, Fox. Great to see you again. Fox is with us as well. Sorry about that.
Because for now, I don't see anything on Q&A or chat right now.
Sorry, I took a little while to get here, to get to YouTube, but I wanted really to finish the demo before we got started. So I have here how to connect PCB connector at equal distances of 5.08 millimeters. I don't think we could specify that. It's just aligns them according to equal distance.
Yeah, so the align command, what it'll do is it'll look at what are the components that are on the extremes. So if you're going to distribute vertically, it takes the top part and the
Mhm.
bottom part, calculates the distance between them, and then divides that by the number of items.
Correct.
So you can't specify it that way. There are other ways to do it. You could use something like, the array tool. So component array under tools is one option. You
Hmm.
can also use the inspector, form a group and then with the inspector line them up and split them however you need to. So there's a few ways to do it.
This is
But the
this is
align command
but
does
this
it.
is the inspector over here, just to let you know.
Mhm.
Okay, and then you have a little bit of control, I guess, at this stage right here.
Mhm.
Right here. Okay. Okay. Let me see if I have any other questions. Oh, I think we were having some internet issues, and that's why it was kind of on the slow side, the demonstration in the beginning. Sorry about that. Okay. I don't have any other questions, none that I could see here on YouTube. No problem, Josh. Thank you for joining us. Appreciate it being here. Okay, so I think we could finish it. I see that there was some Q&A. I'm sure you took care of those already. Okay. Well, greatly appreciated, everybody. Thank you for joining us, Jorge. As always, thanks for uh, helping out with the guys, as well as your commentary as well. Greatly appreciate it. Let me see. Was there anything else I wanted to show? I showed the manufacturing. Oh, and if you're here already, let me just go ahead and save this, and let's take a look at what this would look like in Fusion, since we're already here and we actually have it in Fusion. So let me just go ahead and set this here really quick. So let's go ahead and send this back to Fusion. I'm going to push to Fusion. Almost all my components have 3D models except my 9-volt battery does not have a 3D model. Okay. I'll go ahead and click on push. Okay, it finished. Let's go ahead and take a look at my folder here. To let the refresh. Let's close this. Don't save. And this is what my board looks like in Fusion 360. Okay, as you can see. Okay. Okay, so kind of looks like our board, huh? Very well. I just wanted to show you that relationship that we have with Eagle and Fusion 360 and how you could take advantage of it. I recently did a small little demonstration of a fine tuning component placement using Fusion 360. So go to our YouTube channel and take a look at that one. Thank you, everybody. It's been a pleasure. Thanks for coming. And I think we do have 2 more webinars going on next week. Let me see if I could find the topics really quick. Oh, they're not listed here yet. Okay, very well. Make sure to visit our website and just go to the learning section of the website.